All right, last problem, question number 5. I'm going to, let's get this out of the way. There we go. Going to take a look at this lava jumping problem, starting here at position A. I'm going to come down the ramp to position B, and I'm going to make this jump in an arc, a projectile motion arc, and succeed by reaching this position over here. This is going to be an energy at A equals energy at B. The goal is to solve for what is H in terms of little h, in terms of D, in terms of theta, in terms of G, which is our fundamental constant. At position A, I have potential energy only. At position B, I have potential because I have a height h, and I have kinetic. The problem is I don't know how much kinetic I have because I don't know what V is. And I have to know what V is in order to figure out what the height of H, big H, is. That's my goal, solve for H. So I'm going to go projectile motion. Now, my delta x I know is d. My delta y I know is 0 because I start at this height, stop at the same height. Acceleration is negative g. Okay. I don't know what the velocity is. I'm going to call it v. My goal is to find v. I know the x is v cosine theta, and the y is v sine theta. So v initial for the x is the unknown v cosine theta. V initial for the y is the unknown v sine theta. I'm going to use a little bit of a trick here that basically allows me to say time equals time, because when in doubt on these types of problems, find time. Delta x is v naught t. So d equals v cosine theta t. So t is d over v cosine theta. I'm going to bring that over to this one here. Delta y be v naught t 1/2 at squared. So 0 is v sine theta. This v naught is for the y direction, so don't confuse it with the v cosine theta. Then we got our times t 1/2 negative g t squared. Before you plug in t, let's do a little bit of an algebra trick and factor out one of the t's. I want to do that because it's going to make my life much easier. I can divide both sides by t, because 0 divided by t is still 0. So 0 equals v sine theta minus, if I plug in t, it'll be g d over 2v cosine theta. And my goal is going to be figure out what is v. So let's move, let's see. If I want to get rid of the denominator, I can do 0 is 2v squared sine theta cosine theta minus g times d. What I did is I multiplied every term by 2v cosine theta. If I do it by 0, it stays 0 because 0 times who cares is 0. Wiped out the denominator on the term on the right and then added a 2, a v, and a cosine theta here. And sine theta, cosine theta. So v is g times d over 2 sine theta cosine theta. And that's perfectly allowed. Theta is a defined variable. So I can use it. Sine and cosine, those are trig functions. Those are just mathematical operators, so no issues there. Geez, there we go. Okay, let's come over here to the energy conservation. Mg big H equals mg little h plus 1/2 mv squared. Galileo was right. Mass doesn't matter. G big H equals G little h plus 1/2 times. So I made an oopsie here. This is v squared. I didn't take the square root. And I'm not going to. Okay, I don't need to. Because v squared is right here. So I'm just going to leave it as v squared, which is g times d over 2 sine theta cosine theta. That makes life actually much easier. We learned how g cancels. Doesn't even matter what planet you're on. Big H equals little h plus d over 4 sine theta cosine theta. What a happy fun equation. There's h.